So what we're going to talk about today, and I should swap my screen so you can see my screen, that'd be useful for you, is we're going to talk all about using and building serverless applications, especially with kind of a focus on enterprise-type solutions, using Azure Functions. But I'll go around a couple of other technologies that we have available at Azure as well. Who am I? I'm Chris Anderson. I'm a PM that works on Azure Functions. And before that, the WebJobs SDK, which is important because Azure Functions, as we'll learn later on in the talk, is built off of WebJobs SDK. Before that, I worked mainly in mobile, and before that, SQL. And really, my whole career has been kind of focused around this, newfangled cloud idea of doing PaaS computing. And I kind of like to think of Azure Functions as me reaching the pinnacle of doing that PaaS computing work there. But really, it's been all about trying to make it so that, developers and companies, businesses can walk up and start using technology faster, easier, get to what's actually improving your business, rather than focusing on creating a bunch of technical problems to go and solve, and then you get to the part where you're making your business better. So that's where serverless comes into real handy. What I'd like to do before we kind of start talking about what serverless is, I'd like to kind of talk about where we came from. So before the cloud, even really existed, the world, as far as anyone was ever concerned, was, bring your own servers. You'd go and buy a server, order it, procure it. It would get shipped to some place, and you'd either co-host it or you'd have your own data center somewhere. And you've got this whole flow, and then once you have a machine running somewhere, you can have a VM and things like that installed, then have your business applications installed on that, and then you're managing all of those pieces of the stack, right? Lots of stuff. So it was transformative when we could even remove a single step, and I could just go and grab a VM anytime I wanted to from the cloud. And there's businesses today that would not exist if it wasn't for the fact that the cloud exists, because they'd have otherwise had too much friction to actually get up, get started, and go. And businesses that were already existing and successful were now moving even quicker than before. And businesses all around are just now starting to make this transition in some cases, but many companies have already successfully moved and really accelerated just by being able to take advantage of the fact that they don't have to go through that procurement step. But then there's still a VM to manage, and OS updates aren't fun. And there's lots of other things that just aren't related to necessarily maybe the problem of hosting a web application. And so we have PaaS, right? And PaaS comes in lots of different forms. In the database world, you can just have a database hosted on a server for you, and it's managed for you. You can have containers and have just your containers deployed, and everything underneath the containers themselves are actually managed for you. And of course, you have something like Azure App Service and web apps, where you can deploy just your ASP.NET MVC site, and they run it for you, manage the scale for you. Lots of goodness that comes from there. But I'm still, at that point, having to build up this business application, and there's this translation step between me writing the business application locally and then actually moving it out there. And I'm not sure if any of you have ever wanted to go and just have like a single HTTP endpoint sitting out there or a single task needed to get done, but going off and building a full web application for just that single step feels a bit heavy, right? All I really care about most of the time when I'm building these applications ends up being the business logic that I'm going to end up implementing inside of the application. All the routing, all the fancy middleware, all that stuff is great, but it's all about trying to make me successful and implementing that business logic, because that's what actually decides what I'm going to be doing inside of my business. And so this is where serverless ends up being very cool, because serverless is not just about abstracting away the servers that you're running on, the actual machines, right? Because PaaS is already doing that. The real thing that it also helps abstract away from is, and my slide automatically moved. The real thing that it helps do is also help abstract away from application servers. And so it puts a focus on trying to use, in the case of Azure Functions, just using a function to solve your problem, or in the case of something like Logic Apps, using a workflow to solve your problem. But I'm not having to go and deploy a full BizTalk server or have a managed BizTalk server for me in the case of Logic Apps. I'm not having to go and have a full ASP.NET MVC site deployed for me in the case of Functions. I can literally just focus on that one piece of the building block that I need, and then assemble them together, potentially, into a larger application over time, that I can now kind of work on that more iteratively. It's more granular, and the focus is on what matters to the business, which is just solving those individual problems. So what is serverless? It's exactly that. It's abstracting the servers kind of comes first, because that's what's in the name. It's kind of a silly name. I'm sure if we could have had a committee on it, we would have probably found something similar, but that's the way the world works when These words are decided via Twitter, so that's what we've got. Because it's serverless, in order to know that you need a server, there has to be an event. And so everything inside of serverless is driven by events. This isn't too crazy, because when you think about anything else that we're doing in the world today, we're very much event-driven in how we build modern applications. But if you've ever got an application out there that's just while truing, it's probably not going to fit into the serverless model. You're going to have to find a way of creating an event to go and run that logic. It could just be a timer that runs every 30 seconds, but you're not going to go and have just a while true running continuously forever, because they need to have, well, you can do that, but you're going to pay a lot of money for the actual compute. What you really want to do is break it up into smaller chunks that kind of run when they need to be run. And importantly, sub-second billing. This is really transformational in the same way that just being able to have IaaS, cloud VMs is transformational, because where IaaS VMs really help to reduce the CapEx and a bunch of upfront costs that came with starting up a business or solving a problem, serverless really gets to the point now where I don't even have to necessarily worry as much about optimizing, like, do I have enough applications and business justification for this VM? I can just write a function, and if the function gets used, then I pay for it. But if the function never gets called, I won't pay anything for that function in the sub-second billing model. That's great, because the risk to a business of, like, is this a good idea? Like, are we going to be able to manage scale? Like, what is that going to be? You don't need to worry about that as much, early on in the process. Eventually, everything that reaches a hyperscale is going to start having all kinds of weird side effects you have to worry about. But in the sense of, like, let's just go and have this API available for our employees to call to help make their, travel easier, something along those lines. This is a very, very nice way of going about things, because you don't need to worry about what's the long-term cost of maintaining that solution. If the employees use it, we pay for it. If they don't, we don't. That's great. And so, the way that this ends up being different is, instead of having a giant monolithic application that I had to build before to justify the cost of hosting a server to host that logic often, right? Now I can break this up into loosely coupled components. I can have things coming from lots of different places, all kind of working gently together, rather than them being tightly coupled into a giant application. I can start to move things that I normally had to have inside of a client app, because it was just simpler to have there, outside of a client app, because it's much more easy now to kind of iterate on these things and expand out these applications. Having to justify having some logic in a monolithic app, like you're cautious about what goes in there. Like, you're having to gather as much things as you want into the application, because you're not going to have to version it. You're going to have now these different teams trying to compete for deployment times, all those pieces. Now that it's easier for each team to work independently and each purpose to kind of function independently, it becomes much easier to start really kind of focusing on what belongs where. And similarly, because we don't have to build something which is giant, and giant things need a complex framework to make them work properly under high load and stress, but since functions are each loosely coupled and we do a lot of that kind of scaling at a lower level, you as a developer have a much more kind of micro functionality to worry about. I'll go over programming concepts for Azure Functions here later on, but you'll see that there's really only 4 things you need to be worried about when you're writing a function, which is one of the simplest ways you could actually build an application. And so the benefits, just to kind of summarize this, end up being micropricing, of course, because it transforms the way that we have to think about how we procure and build and manage and long-term host applications. If it's being used, we pay for it. If it's not, we don't. The ease of scale, right? The idea that I can go ahead and write just a simple function, maybe has like all of 5 lines of code, but it's doing a mission-critical piece for you, and have that scale up and down to the needs that I have is great. We often think about high scale, but one thing that Functions does really well, because you don't have to worry about it, is also scaling back down. That's a problem that all businesses could benefit from. I get an email from Microsoft very consistently about all the VMs that I have running that aren't being utilized heavily, and they keep on telling me to shut them off. If I can finish migrating everything that I have over to Functions, I'll stop getting those emails, because I'm only going to pay for those things if I'm actually actively using them. So I'll never get that low utilization email ever again. And I can manage less. This generally comes from using PaaS technologies. This isn't something which is wholly the serverless realm space, but it really still applies. And we've built Azure Functions and Logic Apps off of existing PaaS technologies. And so a lot of the best things that came from paths for management really shine through. And even the places where there might have been rough edges, we've smoothed out, because now we can be very opinionated about how we're going to offer that scaling or how we're going to have your application hosted. We can do something which is very specific, very tuned for what the solution that we're trying to offer is. And so this can change the way that we think about building applications. Right? Instead of thinking about implementing a route inside of an application server, I write a function which is going to be listening on an HTTP request event. Instead of having to write large functional tests and behavioral verification tests that are going to do large end-to-end pieces, my functional tests start looking more like unit tests. You could argue that there's kind of a blurred line there, where when if all I have is a single function, doing a unit test of that function is actually going to be somewhat of an end-to-end test for my actual logic that I have for that function. And instead of building and deploying servers, I'm just going to be deploying collections of functions, right? I'm not having to go and have giant build steps. I don't, people often ask me, how do I get this, big VSTS build process flowing for functions like I have for my existing applications? I'm like, you can do it, but it's mostly static content you're just going to be pushing out to your function app. There's not a whole lot of additional build steps that go in there, unless you're bringing in, shared libraries, which you can do, and in which case that stuff starts to come back into play. But when it's just simple functions, oftentimes it's as simple as just having a Git integration to VSTS rather than the full build and deploy steps. There are some best practices for serverless. You don't necessarily want to be going at it the exact same way that you would normally build your applications. Some things to think about is that you do want to do thick clients as much as possible. If the logic can fit in the client and it won't slow it down too much performance-wise, you want to try to lean towards that. This is really nice just because you can kind of get the most. You end up having much more reusable code. You're able to have these thick clients in these different places. And the other thing to think about here is just to be able to enable cores, since most of the time when you're accessing these things, you're kind of working in the microservice pattern, and oftentimes you're going to be accessing these various services. So I've seen a lot of people go and try to build their Angular application using functions, and they forget to turn on cores, and I just answer their tweet real quick, go flip the switch. Synchronous is nice and simple to think about, but asynchronous patterns end up becoming very critical here, because you're paying for every 100 milliseconds that your function is running, essentially. If you can, let's say that you wanted to go and have an API which abstracted away creating a VM on Azure, right? Creating a VM on Azure can take a couple of minutes, sometimes much longer. You wouldn't want to have your function sitting there and also waiting for that full process to kind of finish, right? That is going to make your function pay for that whole cost. What you can do is you can have your function, basically accept that request, and then put that request off into a queue system, and then have the queue system actually go and start the provisioning process. And then you can have a timer, or you can have a webhook that's sent back from Azure, tell the function that it's finished deploying that. And at that point, I can have another API which just returns the status of that request. And so that means that I'm not going to be running for that entire length of time. I'm going to be running for a much smaller fraction of that time. And it's also much more resilient. If something failed as part of that request, I went into an elevator on the client side, or something on the server side hiccuped, my request didn't fail, right? I just might have had a single part of that request fail. As long as I get that 202 accepted, the thing will finish unless there's an error in the actual system of deploying itself. So this isn't anything to do specifically with serverless, but the async patterns really shine through in terms of when you build your applications. And you're going to end up living and dying by the cloud. If you're kind of half in, half out, serverless can be kind of a scarier world to be in, because inherently, since you're just kind of borrowing servers left and right, you're thinking about something that's kind of working between the two can be a little bit more of a risky deal. The interesting thing about functions is that we do open source our host, so it's possible to actually run our host locally. And if you need to have some kind of local version of it, you can. It's not officially supported by us, but we're MIT licensed, so you can do what you want to. But more or less, things like logic apps, you're not going to be able to run on-prem anytime soon, unless they have an announcement that I haven't heard of. So you really want to make sure that you are doing a lot of development very, very close to the cloud, if not on the cloud. We have an editor in our portal for a reason, because we think there's a lot of folks that will end up not writing any code on their actual local machine for a lot of their scenarios when they're using functions. You can totally write code locally. You can do all your normal local development things by running our CLI locally to test your functions. But you haven't really tested, you should not check in until you've gone and deployed off to one of your own function apps. If you're just relying on your local CLI to actually be a definitive answer of will this work, you're going to have some issues. So you need to kind of just internalize the fact that you're not developing for the cloud, you're developing on the cloud. So with that, let's get into kind of the star of the show, in my opinion, Azure Functions, my favorite service. So Azure Functions, in as short a phrase as possible, is about doing event-based serverless compute, right? These functions are going to be able to run in response to an event that happens out there, and we're going to scale anywhere from 0 to so many VMs underneath the covers. You don't ever need to worry about that number, and we'll just kind of keep that going. We have support for a number of languages. We do a lot of automatic compilation. Inside the portals, you'll see for things like C# and F#, so you don't have to worry as much about the whole build step. It's all about trying to focus on the code and not necessarily the full part of building and maintaining the application. Support for lots of different events, including Azure-specific events, HTTP, and timer. Very generic overview. But really, it's all about events and data and reacting to code. And that's how we get our super awesome logo. Bam, Azure Functions. So I literally just took those. That's our design language pieces. That's what C&E says code symbol looks like. And the lightning bolt's what C&E says the lightning bolt looks like. And so I just slapped the two together, and boom, we got a logo. So that's the background for that design decision. And why they shouldn't let PMs do logos, but we're going to live with it now. What I want to start with before I start showing anything, because it really helps set context for certain people, is just a quick show of hands in the room. How many of you guys are using app service today, Azure Web Apps? Right? So a good fair number of you. And of those people, because I'm assuming they're going to be the same group of people, how many of you are using the WebJobs SDK? So a little bit less, but still a good number of people. So you can, if you need to, just kind of have something click. This is just the Azure WebJobs SDK as a service. For those of you who don't know what the WebJobs SDK is, I'll talk a bit about it. But for those of you who do know, that's essentially what we've done here. We've taken the WebJobs SDK and made it run, support multiple languages, and built the auto-scale features of it. So that way we can automatically scale a thing in and out. Our application architecture, everything that you see there in purple, red, and then, of course, blue is your code for the most part, but we have templates for all that stuff, is actually all open source. And our portal UX is also open source, interestingly enough. And so that means that it's actually kind of easy to see how these things plug together and understand what's going on underneath the covers if you're ever curious. But essentially what we did is the WebJobs SDK was an SDK that we've had around for 3 or so years now that was designed to be able to react to events happening inside of the Azure platform, so react to new blobs or new queues or things like that. And it also helped abstract away from those services. So importantly, when you're working with blob storage, kind of the thought behind a lot of the things inside of the WebJobs SDK was maybe you don't actually care about the fact that you're working with Azure storage. What you really cared about the fact was that you were getting a blob or you're getting a message. And so the focus was on letting you, in your code, abstract away the service and focus instead on what the actual data that you're trying to work with is. And so that means that you can move really quickly. Rather than having to go learn how the storage SDK works or the service bus SDK works, I can, inside of this code here, just work with abstract concepts. And I just have bindings, which allow me to actually bind those variables or parameters inside of my code to those objects that exist outside of my code. And so functions, the first big step that we did there was just take that same concept of that abstraction of talking to various services and move it towards a config-based model and support for multiple languages. From there, it was obvious that that thing was hard to deploy on your own. And so the next obvious step was to just host it as a service. And so that's how we get to Azure Functions, where we go and deploy the service automatically, which does all that hosting and triggering for you. And we manage to scale by looking at the events that are piping through it. The more events we see, the more VMs underneath the covers we end up scaling out to. And if we don't see any events at all, we end up scaling down to 0. And that's how we do things underneath the covers, but you don't ever need to worry about that. You can write your function and trust that it'll scale out when it needs to and scale down when it's not. So what I'm kind of getting towards then is if we think about serverless as an abstraction of your compute layer, and we think about the WebJobs SDK as a way of helping abstracting your other services layer, the services you end up having to talk to or react to, you kind of get this concept of dual abstraction, right? And that abstraction of having to worry about my compute and the abstraction of having to worry about the services I talk to allows me to write code which much more often looks like just very generic business logic. It looks like a lot of what people write for just generic samples because it ends up working with basic data objects. I can work with just a POCO. I don't need to work with an SDK object directly, or I get a JSON object and I work with that directly. And I can oftentimes do very simple operations. I can, of course, do very complex things, but really where functions shines is where I need to do something very simple, and otherwise it would have been prohibitively expensive to go and build an API to do that simple task for me. And functions, it's so simple and easy to use that I can do those things. I don't need to find weird hacks of concatenating things inside of this weird scripting service. I can just call out to a function and let that do it for me. So, of course, there is a concept of platform and scaling, and one interesting piece is that if you think about our binding concept, you can always ignore our bindings to an extent. You need to care about the triggers, because that's what's going to call your function. But as far as the inputs and outputs that I'll get to later on, you can totally not use them and just bring in your own SDKs for everything and work directly with the services. You can totally ignore the fact that we've got those bindings there. Same thing with the compute, actually. We have the ability to run Azure Functions both on this fancy dynamic serverless compute, which is kind of generally steals the show. But if you're already using Azure App Service and you already have a web app running and you've got a VM that you're paying for, you can actually run function apps on your existing dedicated app service plans where you're just paying for the number of VMs and you control the scale. That's really interesting because for things like that you might have been using the web jobs before, like a timer-triggered web job, or a queue-based web job that was doing something very infrequently, you can run that in your existing compute like you do today without paying anything extra. Even though serverless, the dynamic serverless mode is very cheap, it's still some amount of extra. So you can also choose to just run this on the existing VMs you've already bought with Azure App Service. But of course, dynamics kind of the hot thing there because it really helps solve a problem that folks had with the WebDevs SDK, which was figuring out how exactly I want to scale that application. It's certainly possible to go ahead and have the app service autoscale feature listen on a queue, and then based off of that queue length, scale myself out. But what is the right velocity to scale out at? What's my threshold for what's too much work for a single instance? How do I go and click that crazy UX to actually get to that option in the first place? These things really hinder people actually building large-scale web jobs. And so dynamic, by doing that automatically for you, really just accelerates it. So I don't even need to think. I go ahead and create my queue-triggered function, and there's no thoughts to be had for scale until you start getting up to into the thousands of requests a second range. As far as how the billing works, you're going to have two different meters that have essentially 3 units for it. So there's a small amount per execution, and you can just go to our pricing page if you care about the individual amounts. They're, I think, 20 cents per million executions, and your first million executions are free. And it's 0.000008 cents per gigabit second, which is basically our magic metric for calculating memory and CPU time. It's a rough calculation of what that representation of your resource utilization is. And so you can see there that you get the reserved memory that you have, the duration of your execution as your second meter there, which ends up being gigabit seconds. And like I said, it's very cheap, and then the same thing for gigabit seconds. There's also a very generous free tier there of 400,000 gigabit seconds. So I expect the vast majority of you that go off and build some functions for some, just cool side project things would never pay a cent for functions. And even the folks that are using this for larger scale business applications are going to see very, very, very low bills. So I'm not going to get a promotion for bringing in a lot of revenue to the company. Not directly, at least, hopefully. So let's get to the actual functions programming concepts. I said there was 4, right? These are the 4 concepts we care about. We've got a trigger, we've got an input, we've got an output. These are all bindings, right? And I told you you could ignore input and output if you wanted to entirely. And in that case, you've got your trigger and your code. So that's pretty simple. And that's all I'd have to worry about at that point. Your code, of course, can be anything. So you can make your code as complex or as simple as you want to. You can bring in, a Redis library and maintain state in that Redis library and load all that kind of stuff. We let you have things kind of sit outside of your function execution, which you can kind of reuse for shared state across executions. So you don't need to go and fetch contents from SQL every time. You can cache things. It's an optimistic cache, but still you can kind of do that for performance improvements. So you can make your code very complex, but it can also be very simple. And otherwise, the concepts that you have available to you are very easy to use. They're relatively straightforward. And we hope that that simplicity, which we've worked really hard on, ends up making it so you can move quickly. The goal here, in most of the experiences we've designed for functions, was optimizing for speed and ease of understanding those concepts themselves. It's a big focus of us to make sure that for a lot of standard problems, you can get in there and solve them in 5 to 10 minutes. We really don't want you to be spending 3 hours staring at your Azure Functions code editor window if you don't have to. Maybe you enjoy it, but we really want you to solve your problem and get on with your life if you can. Kind of breaking it down even further, the functions programming model is the function is the unit of work, right? This is important because if you think about other compute, the VM ends up being kind of the unit of work, or the application server you write ends up being the unit of work that the system understands. We understand things at the function level. Functions are executed, they start and they finish, and functions have inputs and outputs. And Azure Functions, for the most part, are what you might call pure functions. The system itself will pass you input, and it will pass you out, and will receive your output, and we don't care about any of the state that you produce in the middle. Our system doesn't do anything with that. You can try to maintain your own state inside of your own business logic you implement, but otherwise the system itself doesn't care, and we'll throw away your state at any time that we feel like it, just because that's the kind of people we are. But that's important, right? Because I'm not sure if any of you guys do a lot of functional programming, but that's a very key piece of how like a lot of functional programming languages work, is this notion that your function is a pure function. It shouldn't be trying to deal with outside of state and closure nonsense and all those things. That's kind of how our system ends up behaving. That ends up making certain things a little bit more kind of jump through hoops than you would have otherwise had if you had state. But it also means that things work very predictably. Your function should behave the same way each time, unless you are, inside of your business logic, introducing other state somehow into your system. And you'll notice here that this function has attributes on it. This is actually a screenshot of a WebJobs SDK function. And I include this here even in my functions talk still, just to point out the fact that our C# syntax for functions is the exact same, for the most part, as the WebJobs SDK. So if you have an existing WebJobs SDK and you'd like to port it over to functions, it's Control-C, Control-V, and you move all those things that were attributes before into config. And that's the work that it takes to actually migrate most of these things. Most, say 95%. When you find one of those 5% things, though, file an issue on GitHub, and we'll go and address them. As far as best practices go, once you start doing these things in this world, functions just try to do one thing, right? It's kind of your old Unix command line tools idea there, where you really don't want to be trying to do a whole lot of complex things inside of a function, because you really want to make it, as much as you can, predictable. The same input goes into my function, the same output goes out of my function. And any additional things that I throw into that piece can potentially throw off the whole system. It's sometimes necessary, but you should do it with proper criticism of doing those things, because it's going to add complexity to your function and your system. And complexity, as much as we can, we should try to remove. Functions should be idempotent, right? So to that same point, I should be able to pass in the same input, and for the most part, have my function behave the same. It's a should, it's not a must. You can potentially violate this if you need to, but you'll be much happier if you can let that be the case, where same input, same output. And functions should finish as quickly as possible. One, because you're being billed for it, and no one wants to pay more than they have to. But B, because the longer that any code runs anywhere, the more likely it is to fail for some magic reason. There is a sunspot, and the machine decides to go and do something funny. There's a power outage. These things don't happen very often, but if you have something which is going to be running like 5 hours, that thing's probably going to fail much more often than the thing that you have running 5 minutes. So think about having it run as short as possible. And oftentimes, like there's an example that I often hear of people wanting to go ahead and basically archive their full FTP store. Like every single night they want to archive that off to blob storage. A huge, giant FTP store that's working slowly behind some wall. Great. Don't have a single function just grabbing the whole thing from FTP and all at once moving it to blob storage, and that thing's going to take 5–10 hours. For each little chunk of that FTP store, go and drop a separate queue item in there, and have each queue item basically go and grab a single piece from the FTP store. That way, if any one upload fails, you only have to retry that one small piece. And that means that what normally would have had to retry another 5, 10 hours if something failed in the middle, now only has to retry maybe a 5-minute chunk. And I'm not having to pay for 20 or 30 hours of functions time. I'm only paying for maybe that original 5 hours still, plus a few failures along the way. The function architecture patterns themselves often end up being then microservice patterns, right? You're going to have lots of smaller services that should, for the most part, try to stay as loosely coupled as possible. They can be independent deployment units if you want to. They can also be in the same deployment unit, but for the most part, I can go ahead and have them very, very independent from each other. If you're going to have them talking to each other, you have to worry about versioning between those services. So you have to be thinking about when I update this service and I have a queue that's working between the two of them, how are they going to still communicate together? And moving towards using asynchronous messages between those functions rather than trying to use synchronous messages. Because the interesting thing about synchronous is you have the same problem. If I make a synchronous request from function A to function B, function A's time is, I'm still paying for the time of execution in function A as I'm waiting for function B to finish. So if I can use the asynchronous pattern to basically say, go do this thing, function B, and then later on another function will actually go ahead and accept the response and do the rest of the work, it's much better for my application as a whole because I'm now not paying 2A plus B. I'm paying for A, B, and C. And then scaling and runtime best practices. So end-to-end perf testing is still in fashion. Functions, you can generally expect that you're going to at least have 50 concurrent executions happening at any given time. But it's oftentimes going to be much, much more. And people often ask me what the ceiling is. My general response is as soon as you start going over 1,000 requests per second, you'll probably want to test to see whether what you're doing is actually going to keep up with what your workload's trying to do. And you can always call us and we'll work with you to get higher scale than that. But in the end, depending on how much resources you're trying to consume per call and the duration of your call, you're going to end up with some number above 50 concurrent requests happening at any given time. You want to try to reduce, reuse, and recycle resources, right? So I can take advantage of shared state. I can even take advantage of shared state between functions. So I can have more than one function reference a SQL connection pool and have them all share from the same SQL connection pool. And that can help if I'm doing caching as a part of that same kind of piece, I can actually rapidly reduce the cost of a series of functions, not just a single function inside of my function application, because that memory will be shared across all the functions that are running in that specific instance that we spun up for you under the covers. But that's also important that because those things share memory, if you have a function which is misbehaving and creating a lot of objects, it can potentially impact other functions too. So you want to be careful that other functions you write inside of a single function app don't get greedy and try to grab a bunch of memory because it can impact other functions. And then finally here, the disk is a network drive. It's shared across functions, right? So you want to avoid disk access because anything that you're trying to do over a network like that is going to end up incurring a fairly high latency. But the cool thing about that, it means that if I do have something which I need to share across functions and there's literally no other way for me to do it other than a file that they're all accessing, I can use the file system. Generally, I consider you a liar if you told me that was the case because you can use blob storage to solve pretty much any of those problems and it's going to be a little bit more reasonable. But there's still some cases where files is just easier and maybe you don't care about performance and as a critical thing in your system. You care about it just enough that it's functional for you. You could easily use the file system for that across your functions. And then the other thing is it's just app service. Really, a function app is just a very specialized web app. We've done a lot of interesting things on it, but it's essentially just that. So a lot of the existing app service web app tools just work for functions. In fact, if you go and download your function app contents, right-click and go into Visual Studio and open it as a website, you can right-click publish your that function's website project to a function app via Visual Studio, and it just works because it's basically just deploying it and treating it like a web app at that point. And it only becomes a special function app once the runtime on the function app itself sees those functions and loads them and starts running them. So there's nothing too complex there. That also means things like remote debugging work. So I can actually go ahead and attach a debugger to my remotely running function app, and it will actually work through Visual Studio. So I can get that kind of full tooling experience as well. So let's talk kind of briefly here about putting it all into action, right? And this is where we can go ahead and kind of get into some demos. So first, what I want to do is kind of just get people over the hump of getting started with functions. For existing services, you can start small, right? Let's say that you've got a new thing you've got to go get done, or maybe there's this annoying kind of partly broken part of an existing service, right? Just try replacing it with a function and see if that model actually will work for that particular service. There's a lot of cases where people just have a really old, like, ASP.NET 2 kind of site rolling around, still trying to serve API, regular REST API data and not serving just, MVC content. And like that shouldn't be that case anymore. But replacing the whole thing would be a whole bunch of work. Maybe you really just care about a single API from there working a bit nicer. You can actually go ahead and replace it with a function. Maybe you have API management put in place of it, so you can just kind of swap between the two of them dynamically. And you can kind of play with it. Because it's kind of small and iterative like that, there's very low cost to doing experiments like that of seeing if you can replace existing services kind of API by API or background process by a background process one at a time. Integration scenarios end up being a great place to try functions because for the most part, integration scenarios are trying to take two existing services and building a new process over top of them to actually make them work together. And so a lot of times you've got like maybe your company just had to go and bought another company and now you have to integrate your systems together. Using a function to do some kind of glue work between the two different services could be a very easy way of actually getting it started and working with that. And the nice thing is, because it's cheap and it will only be working as long as there's work to be done, you don't need to worry too much about kind of the planning and cost of supporting the integration. Too much. And really my message that I often give is to just have fun with it, right? Build something that makes your life easier that wouldn't normally justify buying a whole server for. There's a lot of these cases that are coming up and becoming popular today. Like for instance, building a bot that works for your internal team, right? Normally justifying having like a server running on the cloud somewhere where it could be accessed by anyone, to run a bot which just goes and checks your build status would be like, I could do that, but I don't really feel like that's a super good use of resources. But you can actually host the bot framework on-site on an Azure function and have your whole bot hosted there. And if your team decides to use the bot really a lot for the first week, but then you realize, oh, maybe I just care about using my local CLI instead, like it wasn't worth trying to do everything through Slack, that's fine. Your function never gets executed ever again, and you don't have any additional costs for your team. So like those are great scenarios there where you can just get started. And eventually what you'll find is that you'll find things that you really like to solve with functions, and you'll start to move more and more into production. And I've got a great case here in the end of a company which just started using it for some kind of intermediate data processing that they had, moving it more and more into production cases, and then finally they're actually offering Azure Functions as a service to their own customers. So essentially you can write a Azure function inside of their UX, and now customers can solve their own problems that they would have like this inside of their UX. So it's pretty cool. So just some other final kind of signs that a serverless pattern might be useful to you. If you're going to generally have a stateless application, it becomes a lot easier to do things with functions, and it also allows you to reach pretty high scale with functions. The cases where it wouldn't be worth deploying a traditional backend, like that case of an internal bot that you might have. If it's just going to be something which is going to run like 4 times a quarter, right? That's not going to require a VM, but it'd be nice if it didn't have to run on my desktop. You can run it on a function quite easily. If the workload is very sporadic, if it's sometimes just completely nothing, and then 1 week it's going to be very, very popular, and then back to nothing, a great case is actually like this conference. I just found out actually just before this meeting that they were using Azure Functions to help run some of the things on the mobile app. And it's a great use case because none of you guys are going to use that mobile app 2 weeks from now. You could have spun up a server and then spun it back down again after the conference, but this way, they don't even need to worry about spinning it back down again. They can just eventually delete it after the application's done, or maybe keep it around until next year, but it's not going to cost them anything in the interim there, which is really cool. And if your model is DevOps favored over Ops, that's a good thing. Generally, your Ops cost for functions is going to be quite small. You're generally going to have the problem of, is it working or is it not working? And hopefully 99.995% of the time, it's working just fine. You don't need to worry about doing anything at all. And the other pieces, you go raise a support ticket because we did something wrong. We're managing a lot of this stuff for you, the scaling all those pieces. where there is work for you to be done, because there's no such thing as no ops, right? You still need to be monitoring whether your code is still doing the correct things, or if your scale does get really, really high, you might end up running into issues where you need to call us to ask for more scale. But those are kind of the two places where you're gonna have to worry about ops the most in this case. Is gonna be, is my code and the other services I depend on still behaving correctly? And is my scale still staying roughly in the area where things work fine and functions without having to call us for more scale? And the other case is, like I said with the integration, if there's lots of different services involved that need glue together, you could collect all those things into a bunch of different scenarios and have a monolithic server which sits there and helps glue those things together. Or just as you find new scenarios where you need to glue things together, you use a function between them. And it ends up being kind of very clean. And not just functions, but really logic apps is also a great case for this, where I've got a couple of different things I need to glue together. And because I'm only being billed on consumption in a lot of cases, I don't need to worry too much about what the long-term cost is going to be. It's going to cost as much as it needs to actually make the scenario work. So let's actually go through some scenarios here. One of the most popular cases that web jobs had, in fact, I think web jobs, it's still 30% of the web jobs out there are just scheduled web jobs that need to run on some particular schedule. It's timers, right? We use timers to do all kinds of different things. There's a lot of things out there in the world that we don't care to actually go and actually create an event for, right? We can just kind of generically say, about this time, this thing should go and run, and you kind of treat that time as the event. So let's go look at how easy it is to actually go build a timer inside of Azure Functions. I'm sure you're all really happy that we're moving on to demos rather than slides, but okay, let's try not to breathe into the microphone too much either. So here I already have a provisioned function app, and I've got a lot of demos inside of this function app, so I use this a lot. But for you, when you want to go and create a new function app, it's as simple as going to the new, and it'll actually show up in here under compute. And you can click on function app. And from here, the only important piece to kind of mention is that you need to choose between whether you want to use the classic app service plan or dedicated app service plan or the dynamic app service plan. Right now, you can't change between the two of them unless you go and create a new function app. So you want to choose that at the beginning, because you won't be able to change it later on unless you go and redeploy your function app. We might change it later on. That's a case right now. And otherwise, the only other piece here to note is that there's also a storage account that's provisioned with your function app, which we use for help managing the state across all of your various instances. And so the cool thing there is that you can attach your local instance or another function app instance to that same storage account, and they'll actually collaborate together. So that's fairly nice. So going back to this provisioned application that I already have, and you guys could do this from your seats right now if you weren't so listening intently to me, because it takes all of 30 seconds to go provision that application, and you would be able to follow along on some of these demos that I'm about to go do. So I can load this thing, and you'll notice that we have this UX built in to the portal here. We really wanted to focus on making it so that you could get started as easily as possible, and that meant not forcing you to have to go and learn about how deployments work or which editor supports what integration, and it really meant kind of making things just move quickly that way. So here we have on our quick start page just 3 very common scenarios: timer, data processing with queues, and webhook and API. So this is an HTTP triggered function. If we look at the timer here, we can go ahead and create this. And we've got a choice of language here for C# and JavaScript. But we also support a couple of other languages. These are just the ones that get used the most commonly. And so we'll go ahead and create this function. And all that's happening here is, we can ignore this tour for this case. All that's happening here under the covers when it does that is it's taking some templates that we have, and those templates are actually open source. So you can see them, and you can also send a pull request if you have a cool idea for a template that you want to share. And it's just creating a template for a basic C# timer trigger. And it's dropping a file onto disk for the code and a file on disk for the config, which means your config is actually also stored as a file, which means you can check it in, update it, version control it, all those things. And the way that the config then uses secrets is then via an app setting. So you never have secrets actually stored in your code. So it's a nice kind of balance there where I don't have to figure out the API calls to actually configure that trigger or the bindings. I can just define it as config, and then the system itself figures out how to then light up those integrations. So for here, this thing is actually going to be running on a timer. You can see here that it already ran once in this case. What we want to do here is let's change the actual frequency this timer trigger runs. So here what we have is a cron expression. And while we probably will add some fancy UX at some point to make it easier to build a cron expression, it's a fairly simple process. Essentially, what this means is every single time that seconds is equal to 0, and everything else can be whatever it wants to be because it's a star, run the function. So if I wanted to run this twice a minute, I could do something along the lines of every time the seconds is divisible by 30, which is going to happen twice a minute, I'm going to go ahead and call the function. So I can hit save. And I can go ahead and go back to develop. And we should be able to see here that this thing starts executing twice a minute rather than just once a minute. And so from here, I can do whatever I want to inside of my code. I could go ahead and easily enough have an error during my demo. I'll figure out what that is in just a second. I could easily go and implement whatever code I wanted to in here. I could go ahead and bring in the SQL drivers and run a SQL query against SQL, and maybe go clean up old records, right? Maybe I've got something where my certain requests expire in my SQL database at a certain time, and I want to eventually just clean those things from my database just for the sake of reducing the size of it over time. Great, easy to go do with the timer trigger. But let's say that I want to go do a lot of different things, right? And when I want to do a lot of different things, if we want to keep to our rule of doing one thing, we want to go ahead and use queues to kind of dispatch work to other functions to then go ahead and get started. And the nice thing about that is that means that we also get kind of parallelism going on there. If I can go ahead and dispatch multiple queue items, they'll get executed in parallel rather than having a serial execution of waiting for these various things to finish. I can have a bunch of things started all at once, and they'll scale out automatically to new machines if there's too much work, load happening on a single machine. So let's look at how easy it is to actually go and output a queue from a given function. And this is where the WebJobs SDK and the bindings model really comes in and ends up being really awesome. So here you can see I can add a new output. And for this case, I'm going to use queues. I love storage queues for the pure sake that they're very, very simple to use. They don't have a whole lot of frills or features on there, but for the purpose of just having this queue calling this one and having it be very cheap, it's a very, very good service. If you need something which is going to be a little bit more robust and kind of enterprise-grade queues, you can also look at using service bus queues and service bus topics, which are also very simple to use inside of functions. But storage ends up being very, very simple to use. So I can go ahead and hit that select. And then from here, I'm going to name my parameter. This ends up being important because this is going to be the name of the variable I access inside of my code. We actually match that name to the name that we actually find inside of your code. And that's how we actually load or unload the data from that variable. So we're going to call this one output. And we should choose a name here. So we're going to go ahead and choose msignite123. And I've learned to copy paste that because otherwise I will misspell it as part of the demo. And I can choose any storage account here. I'm just going to use the default one that comes with functions because I can use it for demos. Generally, it's a best practice to not use the same storage account that your function uses to maintain state as for other things happening inside of your system, mainly for the fact that each storage account itself has certain performance limitations on it. And so if you're trying to do a lot of queue messaging, you might actually start to slow down your function app because you have a bunch of queues trying to go through that same storage account. So just keep in mind that storage itself has its own limitations for how much throughput it can go through, and that can impact what your function app ends up doing. So here I'm going to go ahead and do this thing that I told you should consider not doing. And so now if I go back to my code, I can go ahead and have an output, a new thing here. And I love coding, output. And I can go ahead and just have this string. And now I can go ahead and do something like this, where now I can say output is equal to hello world. And this is very simple. The right thing to do here is probably to go build a POCO object which has all the information of the task that I want to go have run at that given time. And I can, for my queue, use the type as that POCO class, and we'll actually serialize and deserialize it in both those things. You can share that POCO class across all of your functions if you want to, so you don't have to rewrite code over and over again. And so you can have these strongly typed messages being passed between your functions. But for the sake of just demo simplicity, I'm going to do this. So we're going to run this, and you'll notice that for C#, we're actually going to, when you hit save, compile. So we're actually compiling on the fly using C# scripting. You notice that there's not a whole lot of namespace or class fluff around this code. I'm just writing this single method here called run. And I could actually remove this using system piece too. If I need to bring in other libraries, it's actually relatively simple. You can either include it in a project.json, and it will actually do the NuGet restore automatically for you. So if you have a project.json kind of here in your files, you could go ahead and add a project.json file as a part of this. And as soon as we see that, we'll actually go and run NuGet restore on any packages that we see in that project.json. You can also upload your own shared libraries, either directly via zip file or, of course, via Visual Studio, and then reference those things either directly using a relative path, so #r relative path my binaries, or you can put it into the bin folder at the function app level, and we'll actually automatically load all of those binaries into your function app runtime. So you can just do using my library. So from here, we should be able to do this. And now this thing should have created a couple of different outputs for us. And you can see here that it's since compiled, and then it's run a couple of times and succeeded. So I'd expect now that when I go and create a queue trigger, I'll have a couple of messages to actually automatically start running as soon as I've done that. So let's test that out. And we'll go ahead and do, instead of going through the quick start experience, we'll go ahead and go through the new function experience. Here we have a lot of templates for a lot of scenarios. And this list will keep on growing over time, both from us and from community members like you, potentially you guys, who want to send us a pull request for what they think is a good template. And we have every single check-in gets run through our full end-to-end test suite, so you don't need to worry too much about sending a template up there and having it break our system. We'll tell you that it's broken. So we have very good testing to make sure that each of these templates works and works well for the most part. I say for the most part because some of them can be turned on for experimental features, and experimental features themselves might break, but the template itself is doing the right thing. It's the experimental feature that might break. So in this case, we want to do a queue trigger. And we'll go ahead and do a queue trigger in Node just to prove the fact that we don't need to have the same language thing. They're completely separate if we wanted to. And I'm going to just going to point out here that this is going to be the msignite123, and it's just using the exact same storage account. And so I go ahead and create this. And we should actually see in a very, very short period of time that we actually see a bunch of executions here in the logs, because hopefully all those queue messages are actually getting put out there from the timer trigger. So there we go. We see a bunch of executions now. They all kind of ran at once. It just took a second for the function to be created, and then our listener to realize that, oh, this function wanted all those queue items. And so we went and dequeued them, sent it to the function. The function said they succeeded, and so they were then pulled entirely off the queue. When we pull things off of the queue, Azure Functions running, we hide it, and then when it succeeds, we actually finish popping it out. That way, if a function fails, you actually have robustness in that queue message. We don't actually go and throw it away automatically. And after 5 failures, by default, we'll actually put it into a poison queue, so you can actually do proper error handling if you have a very bad message in your system. So in this case, this was a very simple example where it's going to go ahead and just print out whatever the message that was passed into me is. I found that as I do these demos, going into a very specific implementation or a very specific scenario when I'm showing how this quick start is, can be fun, but it can be a little bit distracting. What I really want you to all kind of internalize is think about how you'd build this without functions today, maybe even without web jobs, right? Going and building some kind of console service where maybe I go and bring in some cron library that does that for me. I have to have that VM running all the time and make sure that it works perfectly. OS updates I need to keep patched, all those things. And then also have that queue trigger. So I have to go write the code, which is actually going to go ahead and pull in that queue. And instead of my timer, have the code which is going to output that queue. That's a lot of stuff before I start implementing the business logic that I've actually want to have get done. And I haven't written any business logic here at all. So everything that I just showed you here was just the short amount of work that it takes to get that idea put together. And now I can start implementing my business logic. If I had done that any other way, it would have taken me much, much more time, both in research and implementation. And then maintenance costs long-term is a whole other story, but that's also going to be a problem for you. So that's really just kind of proving the power of a platform like this, where this abstraction really, really helps you be successful quickly. So let's look at another cool example of the HTTP case. HTTP is an interesting thing compared to the rest of our objects because everything else up inside of our system is generally considered an asynchronous event or a streaming event, right? When you're listening on an event hub, we're listening on a stream, and those things are coming in, and there's nothing waiting for us to actually finish that stream. There might be something downstream that's waiting for us to send something to it, but there's not like something open waiting for us, and it will fail if we don't send anything back to them. HTTP is interesting because most HTTP requests are synchronous requests. You've got a client waiting for a response from you. And so that's where some of the function stuff does end up getting kind of fun because we promote asynchronous as a behavior, but then inherently for HTTP, you need to have some kind of synchronous response back to the requester. So The way that works with HTTP is that we still kind of held true to our model by abstracting away the request as an input and the response as the output. So you don't have a single, HTTP object as your input that you also do some output things on. You have a separate response object that you end up using, and that's how we kind of keep that still pure function model. I say these things only to kind of just talk through what you'll see here. Let me go and actually use a C# function for this. So you can see here that the way that we end up achieving that then is we end up passing you through here your HTTP request message as your input. And this is the normal ASP.NET HTTP request message here. So you can use a lot of existing libraries. In fact, one demo I'll show you here that uses the bot framework actually just plugs that request message right into the bot framework. And the bot framework understands how to work with that. And it just kind of works the rest of the way through the pipeline. That was good, which means a lot of existing libraries and code samples and all that kind of stuff just works inside of functions. And then here, this sample is kind of doing, if you've ever seen me do a functions demo, you've seen this particular demo. You basically go and request something, and it says, please pass a name on the query string or in the request body. The reason it's telling me that is because you may not be able to see it all the way throughout the room, but essentially this code here is looking to see on the query string whether or not I have anything that has the name as the value, as the key, right? Or on the body, if there is anything on the body that has the name property. And if name ends up being null, I didn't pass name anywhere, I'm going to send that message back. And otherwise, I'm just going to say hello name. So let's just go and see how easy it is to use. Just kind of get that name off of that string. And I do world, and I get hello world. And you see here, it's sending me back XML, because Chrome, if you don't tell it what to requests XML, and we honor the request type. So in a different browser, it actually get JSON back, because other browsers sometimes actually request JSON as a default rather than XML. So that's just a fun browser mismatch story. Because this is C#, right? But it's dynamically compiling C#. Every time there's a save, I can go ahead and start doing things. So let's say that I want to go ahead and really more like, kind of ask the question like, hello, so-and-so. I hit save. And we see here that we're going to recompile, and it's going to succeed. And already, it's hot for me. So I don't have to do any additional deployment. There's no long wait for all the VMs that this thing's running on to go off and get it. We've immediately, as soon as the files changes, the runtime picks that up and changes the way that the function app behaves based off of those changes that were made. This makes development really, really quick, right? You don't have, this might be unfortunate for some of you who really like that 5-minute deployment time to go pick up some coffee and go chat with the coworkers. Now you don't have an excuse anymore. It's going to mostly just run like that. What you really need to go do is go and build a build step that has like a thread sleep in there, and then you're fine. But now you got to be creative with it. You're gonna have to work to not work. So it's gonna be fun. So let's go ahead and kind of get back to some of our examples, because as fun as it is to see the simple things, I like to kind of think through the end-to-end things. So we've seen timer. So then you get service event processing. And then here we have an example of a file being added to blob storage. But let me kind of propose another sample that I was talking to a lot of people on the floor last night, and I heard this kind of come up a lot. I've got a lot of data that's flowing through an event hub or IoT hub, right? And I'm piping that through Stream Analytics to actually go and track like threshold alerts and things along those lines. You could have a function do those things, but I think Stream Analytics does that job really, really well. But what you can have Stream Analytics do is every single time that it detects that threshold alert, it outputs a message to like service bus queues, right? And then I can have my functions listening on that queues to maybe go and then send a push notification using our notification hub output binding to a technician that's working in the field to go respond to that event that happened, right? The kind of ease of assembling these things ends up being nice there. And the really cool part about that scenario is that there's no servers anywhere that's actually having to be provisioned to run that event. And if there's no alerts that happen on any given day to go and tell that technician, I didn't have to pay anything for the function's compute at all, right? So that's really nice, because now I can kind of work on a lot of these kind of quality of life features for my employees, people that I'm working with. And the cost ends up being as much as they end up being used. So that can be very, very easy. You don't have to plan ahead for how I would support that kind of thing long term. The other cool thing that we do is combined with logic apps and some of our own bindings, we've actually built bindings to trigger off of things like Dropbox. So we call these things SAS file events. But you have a new file uploaded to Dropbox or OneDrive for Business or a couple of other different providers like FTP. And we'll actually go ahead and grab that file and send it to your function, and the way that the API works is the exact same as blob storage. So let's say that you have code that you've written that works against blob storage, but you end up having someone who's less technical, and you don't want to build an interface to go upload an image to blob storage for them. You can just tell them, OK, here's this Dropbox folder you can drop this into. And as long as it's nothing which is production critical, because I'm not sure how much I want to have Dropbox part of my production workflow, it's a personal decision for you guys. But I can actually have them working with that traditional SaaS service. And it goes beyond just files, right? Combined with Logic Apps, which I'll show a cool demo here. Logic Apps makes integrating with tons of different services out there very, very easy and building a workflow around them. And functions can act as an individual step as a part of that workflow. So now I can build a totally service interaction across a lot of different SaaS that I want to interact with, and plenty of other services as well. So let's take a quick look at how I monitor all the tweets that you guys say about Azure Functions, and do a little bit of work to make my life easy of deciding which ones I need to go and look at and which ones can I come back later to. So for this, if I go back to my thing here, you'll see that I've created this Logic app. And if I go to the edit blade, it'll pull up the Logic Apps designer. And just to kind of do my quick little summary for those of you who don't know what Logic Apps is basically a workflow as a service. It does a very easy way of taking a bunch of different steps that need to have happen, potentially very complex, and it will do that workflow for you and manage it based off of an event that happens. They have support for tons of events, way more events than functions, and it scares me to even think about trying to support that same number of events and functions. They've done an amazing job at supporting tons of different integrations with this. So it's a very, very powerful tool. Here you can see this one that I've already set up, and it's basically they have a new tweet trigger instead of Logic Apps. That every single time there's a new tweet that mentions Azure Functions, and they've got the frequency that I want to pull at, I'm going to go ahead and send a message to Azure Functions saying, hey, you've got to go respond to this thing. My function that I wrote was just called sentiment. And what I'm doing inside of that function is I'm going to send this off to cognitive services to figure out how happy or sad is that message. And then I'm going to return the score back to me so I can kind of see what the score was, and also an emoji. And the emoji is how I visually can just react to the messages. If I see a bad emoji, I'm going to go and look at that message because I really care about making sure that anyone who's unhappy ends up being happy. And then all the ones that are really positive, I'll look at after I've answered the bad message because I need to make myself feel good again. So it's helpful. And then finally, we've got a team Slack that pretty much only I use for the most part. Some other folks use, but it's mostly, I think it's my personal Slack at this point. But it's really great because I can kind of just see a workflow, a flow of messages going through there. I could have just as easily made it a bunch of emails or something along those lines, but I really didn't want to have more email in my inbox because I haven't answered anything all week at this conference, and I'm pretty sure this would just make my life even worse. But Slack is good because I can ignore it except for when I don't want to. So from here, let's go ahead and take a look at how this actually works from the function side of things. Because Logic Apps, it was very easy to just kind of assemble this workflow. How easy is it to write a function that ends up working with Logic Apps? And the cool thing there is that because the way Logic Apps works, they can call us as a webhook. And so we can just treat every single function that we want to have working inside of a Logic app as a generic JSON webhook. And if we actually go in through and set the right things here, which I'll show you, on the Integrate tab, if we go and set the HTTP trigger to be of mode webhook and webhook type generic JSON, the Logic Apps editor will actually go and discover them automatically, and they'll know how they behave. And so you can actually work with that directly without having to go and do anything kind of weird HTTP calls directly. We can discover Azure Functions from within Logic Apps that have specifically those two settings set correctly, because then we know how to talk to them every single time and how they'll behave. So from within there, I can then write my code. In this case, I wrote a simple node function which calls out to cognitive services using the, here's my URL. Note that I do not paste my URL into my code. I store it as an app setting, and then I access that app setting. This is great because this means I can change that automatically via programmatic APIs. And also, none of you guys steal my URL and API key and start abusing my credits, which I can go out of. If I've had times where I ran Azure Functions tweets enough that I abused all of my credits with cognitive services, and I had to go and buy more. So that's a good thing I protect that. From there, I'm making a request directly, and then the response ends up just being this. I can send a HTTP response inside of functions using this context.res for node, and I can set the body, I can set the status. I don't need to play with any kind of weird kind of gateway configuration settings or anything like that. I literally have almost a direct connection between the requester and my function. There's very little in between there that I need to go and also factor into my design. So I can set the status directly, but I don't need to because we default to 200. It's a good idea to do it yourself. Like, you should just say status 200 if you expect it to be status 200, because we might be crazy one day and decide to change the default. We should never do that, but you should always plan ahead. We could always be crazy one day. They might not have me around and then do something really crazy. And then in the body, I send back the score and the emoji I've decided. In this case, my emoji is just a simple kind of compound ternary statement where if it's above 70% positive, I do the medal emoji. If it's between 70 and 50, I just do a simple smile, just kind of neutral. And if it's below 50%, I give it the hanky emoji, which is the poop thing. And so let me see here. The fun thing here is I actually need to go. I did not sign into my Slack beforehand, so I have to probably go through 2FA real quick. We'll see. And I can actually go down to here. I'm already here. And you can see here in this channel that any tweet that you guys have been doing about Azure Functions shows up inside of this pipeline. I can see that people have been tweeting about me and posting some pictures to Twitter, so that's nice. I hope I look good. I'll look at that later. Hopefully, the problem is that one's probably really positive, but then I go look at the picture of myself and I'm sad again. So I'm gonna have to be careful. But yeah, and that's really easy. And this is, once again, a very contrived case, right? This isn't something that's going to solve a super critical business need, but potentially you've got a VP who just wants to see tweets that are talking about the product you guys are working on, and you don't want to go and spend hours building a pipeline or going and using a SaaS service to actually go build a feed for this. This demo took me all of 30 minutes to go build when I first did it, and most of that was learning how the Cognitive Services APIs themselves work. So it's a very simple way of building a tool, and you can, of course, take this kind of to the next level, and you can assemble things. Let's say that every tweet that comes in about my product, I want to go and see if I can look up that person's identity inside of my CRM, and then I can then track interactions or mentions about my product with the person with that CRM. If someone's talking a lot about my product, I can detect that, and maybe my sales team is like, oh, hey, this person's doing a lot. Maybe I should go have a discussion with them. Maybe we could do something to make them more successful, right? That's a really cool thing you can build that would have normally been crazy to go and propose to a dev team. It's like a lot of work. Here it'd be just a couple of different assembly pieces and Lego pieces to put together. And what I'm going to do here is I'm just going to kind of go through quickly these last pieces because I had a lot of fun in the demos. And I want to get to the final demo here where I'm going to show off this awesome story that came from this customer using functions. So you also have, of course, serverless web application architectures. So I've got a SPA or something along those lines, and I can expose an HTTP endpoint that does any number of things. One of the best cases I've seen of this so far is someone replaced their order processing things for some internal IT site. Basically, you could request IT go run an operation, and they had an API that dropped a queue item in there, and that queue item did a whole bunch of automation tasks underneath the covers for them. But they were able to do that without having to build a full web front end. They were able to just add the API kind of easily on there, and it took them very little time to get it done. Similarly, you do the same thing for mobile, right? As more and more companies make this transition into kind of being a very kind of mobile-first company the way that Microsoft has done, you have to start thinking a lot about mobile experiences. A great example of this is, in fact, your Ignite app. There's one of those APIs in your Ignite app which ends up being powered by a function underneath the covers. The use case that I was told by the guy who did it was that he keeps on having PMs tell him different requirements constantly. Like every day he gets a new requirement. And it was way easier to do it with functions where it was a very quick, simple edit than it was to actually go and deploy a whole web service and maintain that web service. And the cool thing is it scales up to deal with the traffic that's coming from all you guys here now. And then later you can ignore it until the next conference rolls around. So it's a great example. And mobile's just like that, right? Even more than web, mobile is very sporadic in its traffic, up and down, depending on what people are doing with their phones at the time. So it's a great case for building a mobile backend using functions. And of course, really is real-time stream processing. This is an example where I was talking about kind of stream analytics. It's a very similar idea. Another use case from stream analytics functions and IoT Hub is stream analytics doesn't really like binary data so much. You can do things, but it becomes harder to work with it. Let's say that you wanted to have data flowing in from IoT Hub. You wanted to go ahead and enrich it slightly with maybe GPS information, and you wanted to take whatever the binary data was and express it as a JSON format. Then you pipe that into another event hub which goes into stream analytics. Now, instead of having to do limited things in Stream Analytics just to kind of restructure the data, I can let the function do that work, very simple restructuring and enrichment, and let Stream Analytics do what it does best, which is that analytics of the analytics of the stream over time, right? That's something that you never want to go and do in your own business logic. Stream Analytics does it really great, but you can do the things which are easier to do with just pure code, like restructuring data. And then I'm going to go ahead and skip this demo for now because I want to get to the other piece of the last part of my talk. But it's really easy to take the bot framework and just kind of run it on an Azure function. And like I said, bots are one of those cases where if you're running a bot, which is going to be used by 30,000 customers, you can justify buying a server for it and doing all that work. But a lot of places where bots shine is just kind of enter-team things or stuff to help make you work faster as a developer, right? Having that conversation with the tool that you're working with, not just these rote commands. That's where bots really shine through, and functions ends up being really good because it's a low-cost way of getting started with that technology. Very, very low risk to work with that technology, and it's very simple to use. And then finally, logic apps. So this is kind of an example of that same logic app scenario, but I also talk about API management. And you can actually build a full serverless application by using API management as kind of your front REST surface area. And you can directly trigger logic apps via their HTTP trigger and expose various things through there. So I actually, for a different conference, built an end-to-end application using logic apps and functions as all of my REST backends. And it was actually really cool because there was very, very little code involved, but I was actually able to do a full, someone uploading an invoice, me processing it and creating a PDF for it, storing it, and then being able to fetch and return that invoice back to those same responses. And so finally, to the pieces, to this last part here. So Plexure is a company which really helps businesses that have lots of transaction and customer engagement data to measure that data, to do some analysis on the data, and then to optimize the interaction they have with that customer, right? And so they've got this great flow here that they have, where essentially they help you go and start emitting data into Plexure via lots of different options. We'll kind of look at a few of them. And then they've got a whole bunch of workflows to help you then take that data and transform it into something which is useful to your business process, right? Because customer A walking into your business isn't necessarily super useful. Customer A walking into your business and they've bought these things in the past is very useful. So they help you go ahead and do that transformation. And then you can then respond back to that customer and influence them to go and make a different purchasing decision, right? So this is a really cool technology in the first place, and there's a lot of event-based things that are happening, right? They've walked into a store. What can I go do from there? Well, they had started using Azure Functions as a way of building some of those back-end pieces themselves, and it clicked for one of them, whereas essentially like, hey, what if we could let customers write their own versions of these things, right? Rather than us going and implementing each one of these ad hoc events that we want to have processed, what if we just gave people the ability to write their own Azure function inside of our experience? And we can let people literally do whatever response they want to any event by leveraging Azure Functions. And because they're serverless, if they only have to charge the customer, they only have to factor in how much of the customer is going to use these things or not. They're not having to worry about provisioning a whole bunch of infrastructure to be able to handle the number of requests that are coming through there. They can rely on our service to handle that for them. And so you can take a look at what they've ended up doing here. They also take real advantage of logic apps for handling a lot of the event workflows themselves. And then they're using functions for all the custom business logic that you want to add into there. And they use a ton of Azure services, so I really love this company. But they've really got some interesting things going on here. So let's go ahead and take a quick demo of how that works. And I would consider this like, really someone's reached the peak of how much they want to use functions, right? They're using functions not just to solve some internal business problems, not just to help make their product behave better, but now they're actually offering functions as a way to improve their customers' lives. So we can take a quick look here if I jump back over and hope that I'm still refreshed. So here I've got a workflow. This is just a sample workflow in a demo subscription that they gave me. And you can see that I've got this zone trigger. And essentially the scenario here is that I'm a business that wants to detect every single time a customer enters a zone. So that might be my store, or it might be like the block that my store is on. And I can define what that zone is. And so it's essentially geofencing. And at that point that happens, I'll know the zone that they entered and what that customer's ID and information was. And then, of course, I can go through here and I can use something that they provide to me to go and analyze their historic purchases. So I can go see what did they purchase in the past. Are they a wine person? Are they a beer person? Do they like this or that? I can go and get all that information for me from the Plexure system. And then if I wanted to build a recommender, the interesting thing there is that I could probably use some pieces they gave to me, but maybe I want some very custom logic. Maybe I want to interact with cognitive services or some other intelligence service that I want to use and build my own custom recommender based off of the data that I know about, the behavior that I'm aware of. And so the thing that they've done is they've added this extensions piece where I can actually write functions inside of their experience entirely. So let's scroll down to the end here. And you can see that they have the Sainsbury recommender, which is what that square looked like inside of my workflow. And this is actually just an Azure function. And what they did was, because we open sourced our UX, they just went in there and took all the components that we had written for our editor and a lot of that stuff, brought it into their code, and then changed it so it looked nice, because I really like their actual their colors here a lot. But it's a little thing, but sometimes the colors can really improve the experience. We're probably going to have to add a little setting there to change your theme in the functions portal. But they just added it in here, and now I can write the code, save it here, and then I can go and test my workflow and have the thing flow end to end for me. And this is great. The way that this works for most services out there that don't have this direct integration is they'd let you go ahead and provide an HTTP endpoint or a webhook that they could call out to. And you'd have to go and implement that webhook on some service. And functions is a great way of doing webhooks, right? If I want to go ahead and react to new GitHub webhooks, functions is a great way of doing those things. It's one of those kind of things that would otherwise might be hard to justify having a whole server for, that functions is very easy to go and work with it instead. So now, rather than going ahead and forcing the customers to go implement webhooks and recommending Azure Functions, they just shortcut it and let you go ahead and just do the direct function itself. And that means that the customers are going to be able to work much quicker because they can just write custom code inside of their portal. It means that they're not sending customers out to a different environment, which means they get a little bit more intelligence on how their users are using functions because they can actually see what they're trying to do with them. And it's less friction for their customers to even get this going in the first place. If I can just write code here rather than figuring out how to spin up and provision a service, and I'm not going to pay much for functions, but I have to go give it a credit card and I have to watch that credit card. Now I just have to go and pay Plexure, and I've got it working. And so that's really great for their customers. So to kind of finally wrap it up here, because my red light's been blinking for 2 minutes, definitely the biggest thing I can say is get started, right? Try functions, functions.azure.com. We have an experience on there that lets you try it without an Azure subscription in the first place. You just sign in with Facebook, Twitter, or Google, and you can go out there and try it immediately for an hour. And it's really just simple to start getting in there. Play with it, have fun with it. And it's built on top of App Service, so I have this other link here called Try App Service. If you do ever want to just build a regular web application, a web API, and host it without worrying about all the same things with IaaS that I was talking about, you can use Azure App Service. And it's got 30,000 applications on it today, humongous, very mature service. And it's one of the reasons that Functions has been able to go as fast as we've been able to and work as well as we do in such a short period of time is because we're built on this very strong platform. So definitely give that a shot as well. And then I think finally I'm supposed to tell you to rate me. If you give me a poor rating, they won't invite me back. So keep that in mind. And open it for questions, but I'm probably going to get kicked out here. So we might want to just meet me after I've shut down. So thank you.